Welcome back. We were talking about Mohs scale of hardness. Now, his name was Friedrich Mohs. His last name was M-O-H-S, so the apostrophe goes behind if you want to use it. I think it's kind of optional. The steel file is harder than the knife blade. And then if we start looking at Mohs scale, we have talc, gypsum, calcite, fluorite, apatite, feldspar, quartz, topaz, corundum, and diamond. It's kind of a weird scale. These are in Vickers kilograms per square millimeter. It's a weird unit. And there's a big distance between corundum, what you know as ruby, and diamond. Down here, there are a lot more minerals. Once we get up here, they get a little bit more spaced out. Okay, let's start looking at the hardness scale. This is kind of cool. Talc, number 1 on Mohs scale of hardness, right here, is so soft you can scratch it with your fingernail. It's so soft we put it on baby bottoms. Here's what it looks like when you pull it out of the ground. I got a big one of these out of a mine in Texas coming back through there once. It goes on baby bottoms, and girls, believe it or not, when you grow up, you also put it on your face because it is a major constituent of makeup. Look at the ingredient on the back of face powder or rouge, whatever you call it. A lot of them contain talc. I think you could save a lot of money instead of buying the makeup. Just go out to the ground and rub your face around in it, but apparently that's not a popular idea. Plus, it would be kind of earth-colored, which is cool and cheap. Gypsum, number 2 on Mohs scale, harder than talc. You can scratch this with your fingernail. By the way, this is called soapstone, too. Gypsum, mined in mines like this. It's left behind by evaporating seawater. Here it is in the aragonite form, crystals. It's what makes up wallboard, and it makes up plaster of Paris. Any of you with the old-fashioned cast on your arm or leg? Finger? Do they put casts on fingers? Have used gypsum. In this case, it's called Iceland spar, and you can see through it. Oops, nope, that's calcite, never mind. But this is a pure form of gypsum called selenite, my bad. This is what you're going to see in Lowe's when you go in there if you're having a house built. Again, both of these can be scratched by your fingernail. By the time we get up to hardness 3 on Mohs scale, it's calcite, and you can no longer scratch it with your fingernail. Here's Iceland spar, and you can see right through Iceland spar, and a cool thing about it, it has double refraction. Anything underneath this, you're going to see twice because light gets broken apart in here. Calcite, calcium carbonate, reacts with acid. Those of you who have swimming pools and you've ever dropped some of the hydrochloric or muriatic acid, same thing, onto your sidewalk, know that your sidewalk bubbles. Why? Because calcite goes into making cement, which makes stucco, sidewalks, concrete. Calcite is used in toothpaste. Why? Because it's so soft and it doesn't scratch the enamel of your teeth. Your teeth are somewhere around a 6 or a 7 on the Mohs scale. Kind of weird, but we are right over here. Way to go, guys. Getting close to diamond. It is what makes up the new Ajax and the new Comet, the new scrubs. If you remind me when we get to quartz, I'll talk to you about the old comets. And it's what makes up Tums. Why? Well, because it reacts with acid to neutralize the acid in your stomach. Fluorite is used in a lot of metal processes, calcium fluoride, and it comes in a lot of colors. It looks like this naturally, and if you get hydrofluoric acid on your fingers, this is what it'll look like. The second day, the first day, you have no idea that this is going to happen. So stay away from hydrofluoric acid. You can't store it in glass because, well, it etches glass. Apatite, used for optical purposes, is a calcium phosphate, hardness of 5. It is really pretty. Bonami. I'm going to skip up to 7 for a reason. Here's quartz on the Mohs scale. Let's go back to our little thing here. We're getting all the way up to quartz now. Silicon dioxide, it's what makes up glass. When you're drinking out of glass or you buy pickle relish in glass, this is what it essentially is. You get other stuff in there like potash, but it's mostly silicon dioxide. The old Ajax, back when I was a kid, was made of this stuff. It was really good at scrubbing. Why? Because it was hard. It would scratch everything down here. Pearl Drops toothpaste has silica in it, which is a softened form of this. You think there's a reason that Pearl Drops clean your teeth? Yes, they're actually wearing your teeth down. There's a reason Pearl Drops, at least used to tell you, use it only once a day. The best glass, in this case labware, is made of quartz. Let's go back to something softer than quartz. Oh, by the way, I kind of skipped over a couple of things. This can still be scratched by a penny, but a penny can no longer scratch this. Your fingernail might be able to scratch apatite, but it certainly isn't going to scratch feldspar. A good file can scratch feldspar, and this white stuff and the pink stuff are feldspar. Von Ami was a softer cleanser than the cleanser that was made out of quartz. By the way, lava soap is essentially ground up pumice, which is quartz. There's a reason it gets the stuff off your hands. It actually scrubs it away. Von Ami made their scrubber out of feldspar for a good reason. Your plates, if you have a porcelain sink, they're made out of feldspar. Von Ami was the same hardness as your plates and your sinks, and it wouldn't scratch it so much. The people making this stuff figured it out. The people making Ajax and Comet, the old version, didn't figure it out, and after a while you'd notice that your bathtub, where you were scrubbing it with the old stuff, was wearing down around the drain. There's a reason. This was 7 and was scrubbing 6. It was actually wearing it down. So what did the Comet and the Ajax people do, since they were actually hurting their own market by ruining the stuff they were supposed to clean? They decided to make their stuff out of calcite. If you look at the side of a new Comet or Ajax can, the ingredient is no longer silica, it is calcite hardness 3. Okay, topaz, it's a silicate, looks like this. I think it's the November birthstone. And ruby / corundum and sapphire, depending on if it has different stains in there, titanium, iron, it'll be sapphire. If it has chromium, it'll become a ruby. And then diamond. If you want extra credit, just donate some of these to the pvONLINE program. And again, silicon carbide, moissanite is about a 9.5. That is a beautiful mineral. Really. Okay, again, fingernail about 2.5. A penny is about a 3.5 unless it's rusty, and that'll be softer. The knife blade a little harder than a 6. A glass plate is somewhere around a 6 or 7. And a porcelain streak plate is somewhere around 6.5 on the Mohs scale. Notice you can have decimals in there. Now this is kind of cool. Nobody ever thinks about this number right here. If you've ever had a pencil that was an art pencil and was really soft, it was a 1. If you've ever had a mechanical pencil that was a 3 or 2.5, it was harder. Those numbers didn't come from nowhere, folks. They came from here. This is the hardness of your normal pencil, a number 2. It's from Mohs scale. Crazy, huh? And we never think about this. Okay, something else. A little giggle here. Cleavage, the way a mineral splits. Mica is very recognizable because it cleaves in one direction. If you ever go to Castles and Coasters, they have big granite boulders there, and in the granite you can find little pieces of mica, muscovite mica or biotite mica, and you can peel them off. Early pieces of mica were what we used for the windows. You could find big sheets of this, and if you peel it off in thin sheets, you could see through it. Not clearly, but you could still see through it. Mica was put in old toasters to separate the areas because it's very fire resistant. Silica, most silicates have a high melting point. And we used to form pieces of mica into countertops because we could set hot stuff on there and it was really fire resistant. The old countertops were named after this, formed mica or formica. Now we have formica that is no longer mica but plastic. Minerals cleave in different directions. They can cleave in one direction, 2 directions, 3 directions, and the directions can be leaning. We can also use X-ray diffraction to figure out how they will cleave. It gets kind of complicated, and I'm not too much into the crystal structure. Here are bismuth crystals. These are artificial. Here are galena cubes. Pyrite, they call them pyrodohedrons, but they're really cubes. Hexagonal beryl. Calcite comes in this weird shape. Wolfenite is a really cool shape, but crystal shape is diagnostic for a lot of minerals. For example, salt, when you look at it very carefully, it occurs in little cubes. Don't believe me? Pour out some salt when you get home tonight and look at it with a magnifying glass. They really are little cubes. And if you break them, they break into even smaller cubes. Calcite, calcium carbonate, breaks into these weird three leaning sides. Also, some minerals don't cleave, they fracture. In this case, this isn't a mineral, this is obsidian, volcanic glass, but I just want to show you what fracture was. In this case, it's called conchoidal fracture. And some minerals are really dense, some are light. If you take pyrite, for example, which is a lead sulfide, it is very dense and you can heft it in your hand. It will feel like it needs to go to the bottom of this. Depleted uranium, which this is 19.1 grams per cubic centimeter. How dense is that? Well, water is 1 gram per cubic centimeter. A gallon of water weighs 8 pounds. If you had a gallon of uranium, depleted uranium, it would weigh 152 pounds. Gold is really close to that. So it always amazes me when in the old westerns people would steal gold, throw it in their saddlebags, and then go riding off. That wouldn't happen. Gold is really heavy. I knew this guy once who had some gold ingots, and he was storing them to hide them from an old friend of his, and yes, she got them back. They were incredibly heavy. A little gold ingot, oh gosh, I want to say the size of a really large candy bar, was all I could do to lift it conveniently. It was kind of crazy. Some minerals are magnetic. Magnetite is magnetic. The old name for it is lodestone. We used to be able to take old pieces of lodestone, float them on a piece of wood in water, and those were the first compasses used by the Phoenicians in the Mediterranean area. And again, some minerals that contain calcium carbonate react with acid, most notably calcite and dolomite. There aren't very many of those, but if it does bubble, you know that it has either calcite or dolomite in there. Therefore, we say it passes the acid test. We know that it is a carbonate mineral. Even today, we will say somebody passes the acid test. It just means we know they are what they say they are. They are true. And again, there are some weird other tests. Double refraction, and if you take ulexite and put it on something, it actually transmits the image. It's called TV rock, even though it's a mineral. There are some minerals that fluoresce under ultraviolet light. There are some minerals that have striations in them, not caused by glaciers, but simply by the way the molecules line up inside. And a few other ones. Again, sulfur is, well, smellable. Metals, you can hammer them or pull them. If you hammer them, they will smash apart. You can do this with a penny. Those of you who have stuck pennies on the railroad tracks, you know about this. Don't do it. Some minerals, like carnotite, I didn't put a picture in here, are radioactive. I was up in northern Arizona, picked up this beautiful yellow mineral. I knew what it was. It was radioactive. I brought it back. Another teacher I was with didn't believe me, put it in his pocket. Probably not a good idea. I won't tell you what happened to that teacher later. And some minerals conduct heat really well. And there's a really weird thing here. Let's see if I can get this in the next minute. We're going to pause there.